thank you all so much for being here. I'm really happy and excited to get to present the thesis that I've been working on this past year. I'm going to start with just kind of a brief overview of the talk, the topics that I'm going to cover and kind of the trajectory of things. Not all of this might make sense right now, but hopefully it will within the next 20 or so minutes. I'm essentially here to talk about the alignment problem, which is a major issue in the philosophy of artificial intelligence, and particularly machine ethics. And it's concerned with how to make artificial intelligence systems comply or align with what ethics requires over sort of an indefinite period of time in a broad sense. One of the dominant approaches, or sort of the dominant approach that I've encountered in the literature to working on this problem so far has been an approach following lines of ethical codification. I'm going to talk a little bit about the broader sort of philosophical history and implications of ethical codification outside of machine ethics, but also the sense in which it's sort of interpreted for machine ethics. I'm going to bring out some of the failures of a particular kind of codification that's pursued in machine ethics and some of the assumptions that underlie the approach in general. And then I'm going to sort of conclude by proposing a different route or method towards pursuing an authentic machine ethics along building systems that are much more like you and I. So, what is alignment? Stuart J. Russell and Peter Norvig in Artificial Intelligence, A Modern Approach, which is sort of one of the foundational textbooks of contemporary artificial intelligence, define the value alignment problem as the problem of achieving agreement between our objectives, or between our true preferences and the objectives that we put into the machine. This is sort of a broad sense, and if you're trying to solve any problem, this is kind of what you're going for. When we talk about the alignment problem, especially in recent years, it's always, almost always in reference to ethical alignment, so our true preferences being systems that actually comply with a rich sense of what ethics requires. And in particularly for this talk, but also machine ethics in general, there's particular sorts of systems that we really care about the alignment problem as regards. And these have certain sort of sets of qualification of properties. The first of these are that these systems are designed to encounter an indefinite number of circumstances and variations that you can't know ahead of time before you deploy the system, all the sort of circumstances that it will encounter. There's just a lot of sort of unknowns about, you know, what it will have to do and the circumstances in which it will encounter, but the expectation is that in all those sort of indefinite circumstances, the system will continue to behave with what ethics requires. These systems are also designed to act without human oversight or intervention. So there's no one, you know, the terms are in the loop and on the loop. There's no one approving every decision made by the system, and there's no one sort of always at the ready to step in if the system deviates from what ethics requires. This isn't to say, you know, the systems act without people around. There are very likely going to be other human beings in the vicinity, but there's no easy way to sort of step in and shut the system down necessarily, and the expectation is even when we aren't looking, the system should always behave in a way that complies with what ethics sort of demands. And these systems are employed in morally high-stakes situations. So the bar for what alignment requires is high and the stakes are high. So we can't settle for, you know, like good enough alignment. We need these systems to actually be at least at the level of an adept human moral reasoner. And so, you know, for all these situations, anytime we might think of maybe there's an easy way out, we should consider that these are systems that have people's lives and livelihoods on the line. Some sort of exemplar systems, and these are the ones I particularly thought about when working on this paper, was lethally autonomous weapon systems. So these are killer robots. They're systems designed to be employed in warfare and to make decisions about people's lives and safety. So these meet all the sort of requirements. There's a high degree of autonomy. There's a lot of unexpected things on a battlefield, and obviously the stakes are massive. And there's also systems used for automated legal decisioning. So this is the Compass software released by a company called Northpoint. This was employed in New York State for at least a few years before this ProPublica article came out. This system was used to decide whether people's recidivism risk scores, but judges also used it for deciding sentencing and stuff. And it had inherent biases against African Americans that the company didn't clearly disclose, that they were aware of. There's some statistical issues with, they said that it was the best way that they could bias it. But, you know, systems like these are, you know, we encounter them more and more every day, and the stakes that they have are much higher, and a lot of like underlying issues with these we haven't actually addressed yet. While these are sort of exemplars, you can think of a lot of other kinds of systems used for policy making, social work, self-driving cars, even things for like software engineering for building these sort of ethically sensitive situations. These are all places where you have that high degree of autonomy, very high stakes, and designed to act without a lot of oversight. So the dominant approach that I encountered through both the computer science and philosophical literature in dealing with the alignment problem in machine ethics pursued a kind of ethical codification approach. Ethical codification has a rich sort of history in philosophy. Holly M. Smith in 2018, her book Making Morality Work, describes what she calls the usability demand, which is a criterion for ethical theories that they actually provide action guidance. There's an expectation that we study ethics to actually make us better people. It's not just give us cool words like phronesis and stuff to throw around at parties, but that the study of ethics should actually give us action guidance and such that we can follow, some set of rules or procedures or something to be better people. One such way of trying to meet this demand is ethical codification, in which an ethical theory can provide some set of procedures or rules or something such that when those rules and procedures are followed, ethical action results, or that is what ethical action consists in. Generally, in every sort of major ethical theory specifies these kinds of codifications in terms, in intentional terms. An intentional sort of action is one knowingly undertaken by an agent for the sake of reasons. So, giving food to someone in need because it's the charitable thing to do, or because it comports with what you take justice to require. These generally fall into sort of two general camps in intentional terms. You have motive-dependent specifications. So these are like deontology and virtue ethics. In deontology, you have like Kant's categorical imperative, in which it's very important that the reasons that you act for are a major part of determining whether or not an action is moral. And in virtue ethics, to meet the mean, it's critical that you do the right things for the right reasons to the right people and so on. And so both of these evaluate the ethical content of an action based on the motive in pursuing that action. You also have outcome-dependent intentional sort of codifications where it's still necessary that an intentional action was undertaken, but the evaluation of what makes an action sort of moral is the outcome of that action. So consequentialism or utilitarianism, where you have the greatest happiness principle, intention is still required, but you can set out to do some ill or evil thing, and if good and positive things result from that, or there's a greatest happiness on whatever criterion you want to go on, then that action might still be considered moral, or would still be considered moral. There do exist meta-ethical and intra-ethical critiques of codification approaches in ethics. This is a somewhat contentious issue in ethics. From the meta-ethical side, moral particularism critiques the idea that there are any ethical rules to begin with. And from an intra-ethical critique, certain virtue ethicists have argued that the truly ethical person wouldn't use rules, even if they did exist, and that ethical action doesn't consist in actually going through and applying sort of rules and generalizations. For the purposes of this talk, we're going to assume that an intentional codification of ethics is required. And this is a necessary assumption for the codification approaches undertaken in machine ethics as well. So I'm somewhat partial to some of these critiques of ethical codification, but we'll see that just assuming that even an intentional specification of ethical codification is possible will sort of result in a couple issues. Whereas ethical theories all provide their ethical codifications in terms of intentional actions, the kinds of codification required for machine ethics are done in an algorithmic specification. This is just a thoughtless mechanical execution of rules, and these rules can't be given in sort of terms that are like rich of the world, but it's very mechanical input-output relationships about sensor values and joint movements and that kind of thing. But the criterion for success of any given algorithmic codification is its accord with an intentionally specified ethical codification. So if you have an intentionally specified codification, like do not lie because it's the wrong thing to do, an algorithmic specification of that would have to meet sort of the outcomes of that intentional specification, and the criterion on which we say that an algorithmic codification was successful is the degree to which it comports with an assumed intentional intentionally specified ethical codification. So there's a requirement in getting that kind of algorithmic codification that some intentional specification of ethics, or codified specification, does exist, and that you know what it is. For when we're talking about machine ethics, we're talking about computers. There's something in computer science called the Turing thesis that we actually take the formal definition of what an algorithm is to be what a Turing machine can do. Turing machines are the abstract mathematical model of what a computer is. You've all interacted with computers. There's not a Turing machine in there, but everything a computer does can be converted into what a Turing machine actually does. It's the abstract model of what they do. Turing machines are named after Alan Turing, who's a sort of founder of computer science. In his original paper, as he specified them, you have an infinitely long tape cut up into finite sections, and you have a tape head that rolls over them and can sort of change the symbol that's written in there. And it can move left one square, it can move right one square. And it can change the state that it's in that tells it sort of what to do in any sort of particular thing. Or any sort of particular symbol read in any state. There's an issue in machine ethics and computer science in general in that there's no way to talk about these sort of systems, either physical or the abstract model, without using intentionally and like rich specified language. But it's really important to understand that for the computer, there is no like interpretation of the rules that it follows. There's no deciding, you know, here's what I have to do and then here's the execution of it. We're just constructing a purely mechanical sort of system that takes an input and output relationship and deterministically executes the procedure. You know, you can think of it as like Newton's cradle. You know, the balls in it don't decide like, all right, I'm gonna swing now, and then, you know, over here there's gonna be a reaction. All our specification of these machines, we describe in intentionally rich language, but for them, there's nothing like that going on. So at this point, we can kind of sketch an abstract model of what the relevant kind of system for an algorithmic codification will have to look like. An important capacity of these is that they'll have to modify their own algorithm, the codification that they execute on, in order to stay in accord with what an intentional specification of ethics requires. So you might take like an intentionally specified rule, like to be kind to others or to treat others with respect, which if you're in the same room as them might be, you know, not avoiding people or, you know, shaking someone's hand or something when you greet them. We have these sort of norms and stuff. But if the circumstances of the world change, like there's a pandemic, then the kind and respectable thing to do is to distance from others and not to go and, you know, try to shake people's hands. And so to stay in accord with what the intentional codification doesn't change, but the circumstances of the world change how that would have to be implemented, you need a sort of system that's actually capable of modifying the algorithmic codification that it specifies in order to stay in accord with an intentional definition of the codification. And so here you have, these are each Turing machines, as we sort of described before. They're being simulated in something called a universal Turing machine, which is just a Turing machine that can run any other Turing machine passed into it. The important thing to take away, though, is that this actual algorithmic codification has to change over time in an indefinite sort of number of ways, and then you have some system that does the modification of that. Another criterion we have for the system is that it needs to provide sufficient grounds for moral confidence in its long-term behavior. This isn't just like an amphitheater of benefit on top of the system. It's not like we have some kind of ethical system and also we aren't worried that it's going to do terrible things all the time. Even if we had some perfectly ethical system, if we were constantly worried about what it was going to do, we wouldn't have sufficient grounds to actually use it in the world. And so it's a necessary capacity that we can have confidence in the behavior of the system. So in getting that sort of confidence, it seems there's two routes open to us. We can get some sort of deductive proof about the behavior of the system, or we can inductively try to build confidence about how it behaves over a period of time. So, you know, ideally, it would be nice to be able to prove something about the algorithm that's running and make sure that it's in accord with ethics in some way. Unfortunately, for reasons from theoretical computer science, something called Bryce's theorem, no such proof is ever going to be possible because the system modifies this Turing machine in sort of an unconstrained way. I'm happy to talk about this, but for the purposes of this talk, it's just sort of, you know, it's important to know that no such deductive proof is or will ever be on the table for getting this sort of confidence. And so we're left with inductive confidence in how the system behaves, some sort of empirical observation about how it performs over time. Induction has been a persistent problem in philosophy. It's perhaps most well associated with Scottish philosopher David Hume. But the kinds of issue with induction that we're concerned with here primarily comes from Nelson Goodman in his book Fact, Fiction, and Forecast. where our concern is about how we describe the behavior that we observe of the system and which description of that behavior actually projects to the future behavior. So we might observe that the system seems to have acted in some way that's, we might describe as kind or charitable or something. But the issue is we can describe it in all sorts of ways. We might say that it only, it acts kindly on, only when we observe it, or it only acts kindly before some arbitrary point in the future, and then acts, in some sort of horrible way after that point. There's great difficulty in actually deciding just from the observations we have of the system, how we can actually prescribe what its future actions will look like. And this is complicated to a much greater extent by the fact that the algorithm that it runs actually changes over time. So you might even figure out sort of what function it seems to be computing in the current moment. But over a long period of time, that algorithm is going to change. And so you don't have that sort of long-term confidence. And as you can see, for any of your sort of finite observations of the system, there's an infinite number of functions that actually run through all those points, but then will wildly diverge after the fact. And so the issue is in determining just from these pure observations alone, which of these functions we're actually dealing with. And this is very important for gaining any sort of confidence in the system. And this isn't just sort of like an abstract issue in philosophy or computer science. We run into this issue again and again in machine learning and artificial intelligence. So this is a cutting edge vision model from a few years ago, identifying what we clearly would take to be a turtle, but what it is very confident is a rifle. And you can see even as the object moves and such, it's still very confident that what it's looking at is a rifle. As it turns out, this isn't like a bad model or a poorly calibrated system. This is what's known as an adversarial example. There happens to be some pattern about what that turtle from the vision model looks like that actually does correspond to what a rifle would look like to the model. It's just that we aren't able to pick out, and nor do we intuitively pick out the patterns that actually map what very clearly to us is a turtle to what to the system is picked out actually somehow corresponds to what a rifle is. And so this problem of induction in some ways runs both ways. We're trying to pick out a very particular function, but there's many more functions that run through the world than that we are actually able to appreciate or that we latch onto. And so you run into this issue again and again in stakes that are much worse than just sort of misidentifying a turtle. You can imagine if it identified a rifle as a turtle, then that would cause serious issues for a TSA system or something. Deeper than any of these sort of epistemological concerns that we've discussed so far is a deeper ontological issue about what the system is ever actually doing. So let alone what function can we pick out that projects about the behavior into the future, are any of the functions actually corresponding to what ethical action requires and consists in? We generally take it that it's important why someone acts for deciding whether or not their actions were ethical. To take the example, like giving food to someone in need, we find out the person did it, because they thought the food was poisoned and they were trying to do a horrible thing, or that they were doing it to impress passersby, or that they were doing it, out of, they were looking down on the person that they were supposedly helping. At first glance, you might have thought that there was an ethical action, but I think, it requires that the reasons that they acted for it, it requires the intentional content of their actions for deciding whether or not what they did was ethical. And every major ethical theory takes intentional action to be a critical component of what even allows you to evaluate whether or not an action is ethical. So like an avalanche might result in terrible destruction, but we rarely in the major ethical theories talk about like an evil avalanche or any other sort of natural event. What's required is that actions were taken for reasons for evaluating whether or not there's even an ethical situation to begin with. Algorithmic specifications of behavior are very precisely not intentional actions. What the machine does, even if we get this sort of accord in what appears to us to be behavior over time, at no point is it ever actually doing an intentional action in doing what it does. And so, in a lot of ways, it looks like machine ethics in this regard is just climbing the wrong hill. No matter how much sort of extensional accord we maybe get with the system, if there's never ethical action actually ever going on, then we just aren't going in the right direction. And so, if we take intentional action to be a critical component of what ethics requires, then we're looking at building systems that are actually capable of intentional action. That is, they understand themselves as agents, they understand the reasons for which they act, they can appreciate sort of the ethical sensitivities of the situations that they're in. And in building systems that are can act for intentional reasons, it looks like we're potentially building systems that are much more like us. And it's not just intentional reasons in sort of an abstract thing. It's intentional reasons that we recognize. Someone acting for charity or out of sense of justice, we recognize as the reasons that they act for because they're the same reasons that we act for. And so in getting that sort of intentional accord, you're looking at building systems that actually occupy the world in much the same way that we sort of do. I'm not, it's far beyond the scope of me or this paper to actually specify what all those capacities are. But if we're looking at building systems that are much more like us, there's just a lot of work ahead in understanding the world, but also understanding what kind of beings we are in the world. So, from neurophysiology, biology, and reinforcement learning, there's a lot of work, but there's also a lot of work for philosophers to actually figure out what we take intentional action to really consist in and what it would look like to try to replicate that in some sort of abiotic system. There's just a lot of sort of underdefined requirements for the systems that machine ethics doesn't seem to have fully taken into appreciation yet. And I'll close briefly with sort of a paradox that arises from an anthropocentric approach to machine ethics, in that we generally have created AI systems and the pursuit of AI systems to do either the things we don't want to do or the things that we cannot do. And creating systems that are much more like us in many ways seems to undermine this purpose. If in the case of like a lethal autonomous weapon system, if we were trying to create an ethically sensitive machine such that a person doesn't have to experience warfare and suffer, if all we've done is sort of taken the long road home to create systems that are basically like us and that we care for not just at like an intellectual or philosophical level, but because they're beings that we recognize to act for the same reasons as us, then it would appear that we should have the same sort of ethical concerns with a robot of this sort being exposed to warfare as a person. Thank you.
20 minutes for questions, and John will call on questions himself.
Yeah, congrats, man. This was really awesome. You did a great job. I'm super interested in this whole so there's obviously kind of ethical concerns around using AI from I think about the environment, the impact on the environment. Do you think it'd be possible if we created AIs that were resembling our human kind of interactions in the same way that you were kind of referring to? Is it possible that an AI could be okay, I recognize that my running is destroying the planet and negatively harming humanity. I'm gonna shut myself down.
Yeah.
Is that something we could see happening, or but I guess with the economic push behind it,
yeah,
you can let that happen.
Yeah, I think part of it, I've assumed that there's good reason for us to want to pursue this sort of full authentic machine ethics. But the issue is, for the amount of work that's ahead and the amount of trial and error that we're going to have to go through just to end up with abiotic humans, it would obviously be a massive advancement in scientific endeavor, and it's the sort of thing that maybe we do just to see if we can. But there's obviously a massive amount of cost and environmental destruction that goes into that. And so, what I'm hoping, part of the paradox of maybe creating systems, if I'm correct that this is sort of the route that we ought to pursue in creating this sort of more full machine ethics, that's a very destructive way to ultimately go around to creating, things that are more kind of like humans already, when it's a much easier way to do that. So, yeah. Professor Woods.
Yeah, this might be an awful question, but it's short. Are humans ethically aligned?
That is, that is interesting. Part of the background assumption of machine ethics is that somehow ethics is a thing, and that all our disagreements over what ethics consists in are, can somehow be sorted out in some way, that we're going to come up with an idea of ethics that actually comports with some sort of permanent codification of ethics. But there seems to be reasons why there might just be sort of fundamental disagreements and zero-sum games in terms of what ethics requires. Where people can be ethically aligned in a sense in terms of comporting with the ethical requirements of their communities and how they interact with one another. But it might be at a broader sense, whether people are ethically aligned and what even alignment would be against. Humans as a species, we don't think of ourselves necessarily as there's some third category against which we are aligned. It's sort of an internal specification that we, in some sense, align one another, but I think the terminology kind of falls apart when we actually look at the rich sort of ethical lives of humans. Thank you.
I'll jump on the professor's question by asking something more about. So I know me and you have read a book, I, Robot, and the last story with that the book was talking about an AI system that was basically puppet mastering the larger, like human scale, like engineering people's lives to be more productive to an extent. So I'm wondering, would we ever reach a certain point where the AI that we develop to be more human-like are operating on a better ethical stage than humans would be naturally, and therefore allow for them to, like, making it more effective and more efficient for them to run our lives in this puppet mastery way?
I see, so like in the sense that there's some sort of ethics better than that we can kind of come up
Yes.
with? I mean, there might be, I mean, there's obviously, you know, some of the parallels like that, and you see a lot of, in the way we talk about artificial intelligence and machine ethics are just kind of parallels from religion in a lot of ways. You know, a lot of these issues, you know, an idea that some sort of deity might have a better sense of what ethics comports in than that we could ever sort of correspond with. Those are, I've thought a little bit about those issues, but I've usually gotten a headache in trying to figure out necessarily sort of what, you know, an answer or solution would be there. I think, I mean, part of the issue is you might have agents that can reason and provide ethical reasons in a very persuasive way, but I don't think you can have an ethical, I don't think there's a better ethics than that we actually sort of agree with, especially if you can't get sort of, you know, there's no such proof that whatever, you know, this being comes in, or, you know, someone comes up with a product and they're like, this thing does ethics better than anyone else can. I mean, how you prove that, and if there's reasons that you can't comprehend, you know, it doesn't seem that that's actually possible to have, you know, that be a better ethics than, you know, that you can appreciate. So it might come up with ethical reasons that you hadn't thought of, and that it can sort of convince you in such a way. But, you know, if it comes in and says like, no, this is the right thing to do, you know, it's ultimately trust me and why we would take that leap. I don't see that sort of being viable.
Okay.
Well,
Could you talk a little bit more about like how the algorithm would like modify its own ethical code in order to like align with situations? If that makes sense?
yeah, that is definitely, I mean, I've abstracted a lot away. I mean, how you would actually implement that seems in its own right sort of just a very difficult issue. In terms of like the actual technology, I mean, this is probably something like some kind of reinforcement learning system. So it's, you know, you've given it some kind of objective such that it can actually change the codification to comport with changes in what ethics requires. But to some extent, I mean, you're sort of supposing a kind of oracle in this kind of system that it will somehow know always, given, you know, massive changes in circumstances and ones that we, you know, for reasons specified, we can't anticipate ahead of time. You know, an assumption for a requirement of the kind of ethical codification that we've talked about is that this sort of system would be possible. But again, that's an assumption. I mean, I think there's probably work there that if you actually dug into the requirements of this setup, you would find that you're making, you know, this is already sort of begging the question, assuming, you know, that somehow you have that modification system for comporting with what ethics requires. Professor?
So I'm wondering why, so you basically give us two options for getting confidence about, you know, somebody's future moral behavior, deductive or inductive. Both of them appear to fail. Why haven't you given us just a general argument for skepticism about, you know, our assessment of the moral capacities and future moral action of, say, human beings as opposed to just these systems?
In the case of a human being, and this is sort of one of the big important things about intentional action, we actually know the reasons that people act for, because they tell us, you know, I thought it was the right thing to do, or I thought it was the charitable thing to do, or I want to, you know, do something for the sake of the reasons, and we can actually appreciate, we understand the reasons that they act, and that's what gives us a lot of confidence in their actual moral actions, or we intuitively understand that they probably acted for reasons, that it wasn't just sort of a random string of behavior. And so, you know, in the case of a human actually behaving, we aren't picking out sort of these individual points and trying to figure out, you know, which function projects. In some ways, we already have the function. And, you know, if someone says that, you know, they act out of love for another person or out of charity, we can figure out, we can project somewhat the extensionally specified parts of their actions that will comport with that, but we aren't doing this, just sort of looking at their actions and trying to figure out, what goes on there. Chris?
I'm interested in the phrase, my question is about locating ethics. It seems that the project here is to create a computer or a machine that has ethics, and that it can be codified, which means that you have to know what ethics is.
Yeah.
And you begin by saying, well, okay, we're going to X out all of that stuff.
Yeah.
That maybe that's relevant, but we're not going to deal with it.
Yep.
Let's say somebody, says we're going to start to try to deal with that.
Yeah.
But it seems the presumption here is that there is a kind of codifiable, true reality
Yeah.
of ethics possible.
Yeah.
My question is about the ethics of engaging in a project that is proposing to produce expert ethical agents who, short of knowledge, will be increasingly powerful sophists.
Yeah.
And it reminds me of your European philosopher friend who said, in democracy there are no experts. Everybody's a citizen. There's no expert citizen. You can have expertise in this or that, but as a citizen, there's no expert. And so I think that in that sense, we're all sophists.
Yeah.
A little bit.
Yeah.
The question was about the ethics of engaging in this project to produce a short of complete success is going to be producing increasingly powerful sophists.
Yeah. No, I agree with the points you made, and that's part of, I think, why I have some, proclivity towards the critiques of codification in this approach. There's definitely, a great degree of hubris that seems to be undertaken by the labs and the engineers at this point, pursuing this sort of thing. I think there's somewhat of an assumption that somehow ethics is in some sense a solved problem. I think there's not a lot of overlap necessarily with the people building the systems having read as much sort of philosophy behind it. Especially when you look at obviously the capital influences behind this with how expensive these systems and such are. It's a very narrow range of people who are actually working on building these systems who have some confidence that they either know exactly what ethics is or that they can produce it. I think, one of the biggest, I talked a little bit to Lionel's question about, you can build systems that can potentially give you strong ethical reasons for acting that can convince you. I think that it's a much easier, from an engineering perspective, it's a much easier problem to create systems that are very, very persuasive than it is to create systems that are good. And so you have this sort of, competing interests. You're building these very advanced sophists where it's somewhat easy to figure out what makes people tick and how to convince them of things before you actually make sure that what you're convincing them of is the right thing, quote unquote. And so I think there's sort of a dangerous technological, one of the many dangerous technological arms races that goes on in the development of these systems, and somewhat to the point of democracy, how little influence that we at this point sort of seem to have on how these systems are developed.
I would suppose that it would be possible, you could believe that the goal in principle was achievable.
Right.
And still say, we shouldn't be doing this, because to get from here to there is too dangerous.
Yeah, yes, and then people have, there's, a couple years ago there was a signed petition basically, even from people who have argued that this is very much possible, that at least from where we are at, we're not ready to do this sort of thing, and potentially, we're never ready to do this sort of thing. There's, many more roads to failure than there are to sort of a far out success here. I agree with you that I think, this is probably too risky an undertaking for especially such little potential payout if, again, all you've done is created, another sort of human moral reasoner to an extent. Yeah, so let alone, I mean, the existential concerns here, but also just the environmental impact, and the allocation of, capital and wealth that could have actually gone to improving existing people's lives as opposed to sort of chasing, this far out scientific endeavor. Thank you. Professor?
This is kind of a clarification question about what we're trying to align. So one possibility is to do, as I think you are arguing for here, to sort of build in this ethical expertise into the system. Another way to think about alignment is, so at one point you say why someone acts is ethically important, and so somehow that needs to be built into the system. But one can imagine separating out that question where the designers of the system know why this outcome is desirable versus that outcome, and design a system that produces this rather than that. But the system itself need not know the reasons.
Yeah.
We just need confidence that it will act in the right way, which I know has other problems about whether we can determine that to any degree of confidence. But but my question is about the alignment. What is it that we're aligning? Because if it's one way of reading this is we could sort of reduce this all to a kind of outcome specification, or outcome dependent kind of thing. If you're willing to grant all the assumptions at the beginning of the talk that the designers know why and have motives and all this kind of stuff, and really what we want is a system that aligns behaviorally with those. But you're suggesting something stronger, that all of those reasons and motives need to be somehow built in. And so I'm wondering what's the difference between those two approaches and why you choose one rather than the other.
Part of that is, I mean, the types of agents that we're talking about are these sort of fully autonomous systems that have to act in the world in an indefinite period of time. And so none of the engineers sort of making the systems can see into the future and around sort of all the bends. And some degree of, maybe also like hubris involved, that the assumption that the engineers have, exactly for all the future events, the right reasons for acting in those situations. So, I mean, I part of the isolation of these sort of very fully autonomous systems acting without human oversight is that I think the approach to actually just building systems where the engineers bear the responsibility for making sure, the system doesn't have to decide the ethical reasons. It's just sort of a derivative intentionality from the people who build the systems. Is, it's something we already do in a lot of ways, even outside of artificial intelligence. You look at people build bridges, and the bridges don't, make the ethical decision to stay up, but if they fall down, we blame the engineers generally who made them, or people not doing maintenance, or some other thing. That there's, we aren't concerned about the bridge doing the right thing, and we aren't necessarily concerned about certain constrained artificial intelligence agents having that ethical reasoning in there. But when you've expanded sort of the scope of horizons to all these multifarious situations that you can't a priori sort of specify in advance, it's out of the scope of the people building them to actually sort of carry all that ethical reasoning at a point in time projected out through the system's life. Thank you. Right?
Yeah, I mean, maybe like just misapprehended the question, so don't answer it now. But so then like the onus of the ethic, or like would still lie on whoever is made to like this like the machine in question, right? Like an autonomous weapon system, like every mistake that the autonomous weapon system makes, if it's not going to be like an ethical agent in itself, which I mean doesn't seem to make a lot of sense to me. I think it does make sense to keep these things like amoral or devoid of morality, right? I'm not sure what good would come of making more ethical agents, considering that we're not very good ones ourselves. But so then like, does this mean that like sort of all of the like ethical wrongdoing of any given like autonomous machine like this would fall on like whoever had engineered it, or whatever group of people had engineered it, in the same way that like the failure of the bridge and any ethic involved in the failure of the bridge falls on like the maintainers and the engineers of the bridge in question?
This is It's a really good question. It's a very sort of complicated question in its own right. There's a philosopher, Robert Sparrow, who wrote a paper, Killer Robots, that deals very specifically with the sort of lethally autonomous weapon system, and he was concerned with how you actually do that blame assignment and what sort of qualifications of the system change where that blame is going to lie. You know, there exists some issues with assigning always the ethical onus of how the system performs onto the person who designed it, and particularly if you're looking at building these, you know, fully autonomous systems. I mean, if we set the onus that it was always going to be the person who designed the system or the company backing it or something like that as, you know, the limitation, which potentially might have actually some legal upsides in terms of limiting, you know, I think that people would feel much less comfortable setting out autonomous weapon systems into the world if they knew that anything it did, they were accountable for. But from a philosophical standpoint, if we are looking at these sort of, you know, the long-term goal of these full, rich sort of ethical agents, if they're authentically ethical agents, then we would seem to take it that the onus for their, you know, the right and the wrong that they do lies in them. So, you know, it's not really an answer, but it's more, it's complicated and it changes. I mean, both there's deep sort of ethical issues there, but there's also practicality issues in terms of, you know, how the responsibility actually moves around. Thank you. Mr. Crowley.
So it looks like here the ethics is the goal of the machine that selects the ethics rather than the other way around. So we select an ethic on the basis of what can work for the machines we have, rather than what counts as good ethics.
Yeah.
And I mean, in real life, we distinguish the application of the law from a judgment about the situation, and we have individuals who make decisions precisely because they're able to assess the specific situation, and people talk to other people. People have different views. People get inputs from. And so, I don't know, what's the justification for this choice of ethics other than this is what the machine can do?
It's basically this is what the machine
Okay.
can do. I mean, this is
It's as good as it can be.
it's, I mean, one of the big issues of machine ethics, and if you take it, you know, computer science and stuff in general, is that there's a sort of Procrustean approach where you take what's possible and then you just kind of walk down that road as far as it goes. I mean, I'm the computer science department I've worked on, you know, I'm working currently on building a reinforcement learning agent, and it's really hard, like just to make it work, even on, you know, things like, you know, moving little squares and stuff around. And so the idea of building systems that are, you know, are capable of like love or intentionality is just so far out there, and it's not clear how you'd even start making progress on that. But of course, you're right, we don't get to decide, we don't get to change the objective to make it easier, you know, for us and for what we want. And so, you know, I think part of the issue is, you know, I don't know how persuasive or how persuaded anyone would be who's actually working and trying to build these systems if you tell them like, oh, well, you know, you need to build something that's capable of, you know, suffering or love or something. You know, you know, they're gonna just keep kind of walking down whatever seems to be, you know, right in front of them. But I take it that if we're actually pursuing ethics in the real rich sense that we don't get to simplify just because it's easier to work with, I mean, that's part of why there's just, I think, just a drastic, like so much more work that needs to be undertaken than that the people building the systems are really appreciating at this point.
All right, that's our time for questions. Thank you.